or 3.1 in Vertex form. So it's super exciting. And you learned it yesterday. So it's going to be easy peasy. So yesterday we kind of looked at what each part did. So now we're putting them all together in one equation. So if it's the number in front of the x, it's going to control the direction, because if it's negative, which way do you open? Down. If it's positive, it's going to open up. Okay, so the direction is linked to whether it's positive. So positive is up, and negative is down. Now, we did all these graphs yesterday. So what we're doing today is we're combining all the pieces together. Okay, and it also controls the width. So we know if A has a value of 6, am I going to get a really wide graph or a really skinny graph? Skinny. Okay. So if it's greater than 1, your graph's going to be skinnier. If it's a fraction that's less than 1 but greater than 0, it's going to be wide. Okay. The H. Now this, hopefully you got from last night's homework. You did a little bit. This is the x-coordinate of the vertex, but it's also the horizontal shift. So that you're moving either left or right. Now remember that in the brackets, if it's subtract 2, that means you're going right 2. If it's an add 2, that means you're going left. X does the opposite to what it tells you. Okay? And K is the y-coordinate of the vertex or the vertical shift. And this one does tell you the straight story. So if it's an add 3, then you're going up 3. If it's a minus 3, you're going down 3. Okie dokie. The nice thing about vertex forming is when you see it this way, when it's written this way, with the brackets, and the squared is on the outside, we know if it's a square, it's a quadratic, we know it's going to result in a parabola. It's going to result in one of those kind of graphs. So in math, if you can visualize it in your head, you can see it in your head, it helps. I always end up having to sketch. If I'm doing something, still now I sketch a rough graph to kind of help me. Like I was helping somebody with a triangle question, and I had to draw it so I could see the shape of it. It's not perfect, but I can see it. All right. Okay. So, how to sketch a quadratic function. Identify the vertex of the function and plot that point. Decide if the graph opens up or down. You guys are smart people. Now, okay, this is what. So step 3, I'll give you the easy step 3. Okay, so step 3, you can always default to a table of values. So what I would do is I do my x, y. Now remember, sometimes we pick our -2 to +2, we don't get the vertex in it. So I always put the vertex in the middle. And then I pick some points to the left of the vertex, gentlemen. To the left of the vertex and to the right of the vertex. So if we do a table of values, that's the way I would do it. Now, you guys are like, I'm comfortable with the table of values. I know how to use a table of values. Life's good when I use a table of values, and there's absolutely nothing wrong. But there's a quicker way to do it. There's a pattern, and that's this one. So you can pick this one, option 1, where you do a table of values, you feel comfortable with it, or you can pick this one where you learn the pattern. Now the pattern is, so you're going to go away and up. So it's kind of like a table of values, but it's always a distance away. It's not a coordinate. So you would go 1 away from the vertex. So one away horizontally, and this would be your up, down. And it's always from the vertex. So if you go one away, so that'd be one on either side, both left and right, you would go one squared from the vertex up or down, depending on whether you're opening up or down. If you go two away from the vertex, then you would go two squared up or down, depending on which way your graph's opening. If you go three away from the vertex, so it's always away from the vertex. And I will tell you, everybody hates this. They hate this pattern thing. They say, I don't get it. It makes no sense. Why did you teach it to us? They do the table of values. They get comfortable with the table of values. And all of a sudden they start doing the pattern because they realize they're both the same thing. So if you don't like this one, because what the heck is away and up, don't worry about it. Don't use it. Table of values and graph those points, okay? So I want you to understand that nobody likes this at first, and then once it clicks, it's like, oh, that's so easy, so easy. All right, so let's do some math. Let's graph for funsies. I probably should change these because these are like the worst coordinate planes. Are really dark. Anyway, whatever. I hope I was efficient. Okay. So the first thing I'm going to do is I'm going to identify the vertex, because this is in vertex form. So vertex form tells you what your vertex is. So your vertex are right there. So inside the brackets is the x value of the vertex, and outside the brackets is the y value. Now, I'm going to pop back to this one for a second. Notice the equation has a subtraction sign in it, right? So if we go back to this one, which way am I moving? Am I moving left or right? So I'm going to positive 2. So my vertex is going to be positive 2, positive 3, even though there's a subtract sign in there. So, all right, let's graph. So what was the first step? So I found my vertex. I'm going to plot that point. Here's the thing. I need increments on this, right? So what do you guys want to go up by? You want to go up by 1? Do you want to go up by halves? Do you ones? Just so everybody's okay with that. Okay, so they're tenths. You don't have to label every one. You just have to tell me one number, and so I know that each one of those has a value of 1. So the increments are the first thing I'm going to label. Okay, so now I'm going to plot my point. So it's over 2, up 3. There's my vertex with me. Yay. Thanks. Does the graph open up or down? Is there a number outside of there? What kind it is? It's the invisible number 1. What kind of 1 is it? Is it positive or negative? Positive, so my graph is opening. I do that a lot. I just throw my hands in the air. Okay, so if I were to do a table of values, because I think that's where we're most going to be comfortable with, and you guys can, I'll show you both. All right, so what did I say to do? I said to take your vertex and put it in the middle of the table. Right? That's what I said to do. So I'm going to pick some values left of the vertex. So what are some values left of the vertex? Okay, so let's do some easy ones. 1, 0. That's exciting. Now I'm going to pick some values right of the vertex. Oh, how about 3 and 4? All right, so now using my equation, I'm going to substitute them into my table of values. So my first one is going to be f of 0 is equal to 0 minus 2 squared plus 3. So what is that? Negative 2 squared is 4 plus 3, 7. Okay, if I put a 1 in here, 4. If I put a 3 in here, if I put a 4 in here, hopefully you guys just like, because it should be the same on both sides. All right, so let's plot those points. Okay, so 0 and 7. And they're going to be connected with a smooth curve, not a V shape, but a curve. And ta-da! I've dropped my graph. I like the Excel as well. Okay, so don't erase yours. I'm going to erase mine. Okay. So the first thing I do is solve for my vertex, which is 2, 3, over 2, up 3. There's my vertex. I decide that it's opening up. Now I'm going to do my pattern. So my pattern was 1 away from the vertex on either side, so to the right one, and I go up 1 square on the plotted point. I go 1 away, and I'm always to the vertex. So start at the vertex, go 1 away to the left, 1 squared up. There's my point there. So that would be at 3, 4. And this one is 1, 4. So this is the exact same points I got in my table of values. And so the next one was I'm going to go 2 away from the vertex. So 1, 2. So again, I start top at my vertex. And I'm going to go 2 squared up, which is 4. So 1, 2, 3, 4, which is here. I'm going to go 2 away from my vertex to the left. 1, 2, and then 4 up. 1, 2, 3, 4. I get the exact same coordinate pairs. I just didn't do any math. I didn't substitute any values in. I just followed the pattern. So it gets a little bit more complicated when there's an A value, when this is like 7/14. I guess it's 1/2. 7/13. That would be really difficult to do. I'd probably go to a table of values and use my calculator. And you're like, I'll never get up those kind of numbers. Yeah. Okay, so that's that one. So you can do a table of values. I think you guys are probably going to be more comfortable with the table of values to begin with. So no shame in that. Okay, so these are still the same, 10, 10, negative 10, and negative 10. So the first thing I'm going to do is plot my vertex. So where is my vertex on this? Okay, so plus 2, negative 1. Remember that in the brackets, it never tells you the straight story. If this is subtract 2, you're headed to the right. So that's going to be at positive 2. Why tells you the straight story? Okay, so I'm going to plot that point. So positive 2, negative 1 is right there. And then is it opening up or down? Up. And what do you anticipate about the width of your graph? Is it going to be narrow or is it going to be wide? It's going to be wide, right? Because it's a fraction. Okay, so let's do our table of values. And I said we're going to put our vertex right in the middle. So I've got 2, negative 1, and I'm going to substitute. I'm going to substitute into my equation. So I have f. Ooh, we're going to pick some values. So 1 and 0, 3 and 4. So I'm going to put 0 in first. Okay. A third. Do not change it into a decimal. We're going to deal in fractions. Okay. And it's mumbling at the front, which is good. So we're definitely, so we are going to have, I'm just going to work off the page for a second. No, we're complicated. So we're going to have f of 0 is equal to 1/3 times 4 minus 1. You guys would agree with me? Negative 2 squared is 4. So then I'm going to have 4/3 minus 1. And the 1 can be written as, I need common denominators, right? 3/3. Love it, you guys are brilliant. So my answer is a positive third. All right, so now I'm going to tell you, oh, that's a bigger eraser. That's a third. All right, so I'm probably going to do the math on a separate piece here. So if I put 1 in there, I'm going to have negative 1 squared, which is positive 1. Positive 1 times by a third is a third. A third minus 1 is negative 2/3. Okay, so if you've done the hard math to this point, if you trust your math, and you check with your friend next to you, and they also have the same answer, you probably could go to doing just good times. Who doesn't love math? Okay, so we said we were just going to copy this, so this would be a negative 2/3 and a positive 1/3. Okay, this is going to be a disaster to graph because you see how smaller things are. You guys are going to do way better than I am, but you know what? We've committed to the scale. So should we change our scale? You're just like, no, we're going to draw a tiny little graph. All right, okay. I would change the scale, but if we're committed to this, then let's do it. So this is going to be 0 1/3 right there. And then I have 1 and negative 2/3, so right there. Right there. And then right there. All right. Now, if you try to do the pattern for this one, it's not going to work. Because if I go 1 away, and then I go 1 squared up, I'm here, and that's not on there. So with the pattern, if you have an A value, doesn't matter what A value it is, if it's 600, you still do this. You go 1 away, you go 1 squared up times by whatever the A value is. And you go 2 away, 2 squared times by that. Now, so this is getting ugly, right? I'm going to use the pattern when I don't have an A value. I find when I have an A value, things start to get yicky. I don't know if that's a technical term, but that's how I do it. So I probably only use the pattern when I don't have an A value. Or if I have an A value that's next to like 2 or something, I can use quickly. I'd probably go to my table of values for this. All right, how do you guys feel? Could anybody see themselves using the pattern after a little bit of practice? Okay, fair enough. I really like first you're like, no, right, sticking to the table, stick to the math, I trust it. Okay, good times. All right. So how many zeros? Super excited. Okay, so zeros are just another name for x-intercepts. Hopefully that helps you with last night's assignment. Hint, hint, nudge, nudge. There is a question regarding this on last night's assignment. So zeros and x-intercepts, same things. Sometimes we call them the roots of the function. That's another name that we give them. But usually zeros and x-intercepts. All right, so here's the thing. I'm asking how many. Chapter 4, you're going to tell me where they are. In chapter 3, you're just going to tell me how many I have. Okay, so here's the deal. There are 2 different types of questions. You've got how many, and you've got where are they. So it's like saying, how many students do I have in my intro class? I have 30. Where are they? No clue. because they are all off doing something else right now. I'll know where they are next period, but right now, no clue. All I know is how many I have. So today we're going to work with how many. So you got three options. I went a little bit crazy with my arrows. They're very bold. So the option one is you have 1, 0. That means you have one x-intercept. That means your vertex is on the x-axis. The other option is you have 2. The parabola crosses the x-axis twice. Pretty easy. And then this one, there's none. There's no zeros. We had one of those yesterday. We graphed one of those, and there was no x-intercept. And that's a valid answer. But again, you have to state it. You have to say no x-intercepts, none, something. You can't just leave it blank. All right. So this is going to be a visualization technique. Okay. So first thing you're going to do to figure out how many, not where they are, but how many x-intercepts we have. We're going to look at our A value. Is your graph opening up or down? That's all you got to decide. You're going to look at your K or look at the vertex. Find your vertex. Yes, my vertex. It's opening up, it's opening down. Visualize the graph, and then you're going to say how many. Because basically, if you did this for 1 day, you're not going to be visualizing something. It's really quite easy. So if I give you this equation, I'm making this up as I go. Okay, so this is terrible. Everybody agree with me? The only number I like over there is maybe the 4. Okay, so where's my vertex? Okay, so where's my vertex? 7/13 and positive 4. So we know it's definitely less than 1-ish, but it's above the 0. So it's somewhere, we'll say right here. That's my vertex. Okay, so I'm visualizing this in my head. I'm drawing you a picture because you can't see what's going on in my head. Pretty scary up there. Does the graph open up or down? Down. So I know that my graph at the vertex is going to open down. Right? Okay, so these are terrible numbers. There's nothing nice about them. I'm not really asking you to graph it. I'm asking you to visualize it. So how many x-intercepts do I have? Okay? So it doesn't really matter what the numbers are. You just have to have an understanding of where things are located. Chances are it's a lot skinnier of a graph. I probably should have drawn it skinnier, but whatever. You get the idea, right? All I want to know is how many x-intercepts. All right. So, okay. Ooh, trick question. Oh, right off the box, there are the trick questions. Where's my first x? Yeah? Okay. So this could be written as, if that doesn't jump off the page here, if there's no brackets, that's the same thing as saying that, right? We just move these boxes right to 0. So my vertex is going to be at 0 and -3. So if it doesn't have brackets with the x, you can assume, you can know, you really understand that the x coordinate of the vertex is at 0. All right, so that means my vertex is here. Do I open up or down? Up. How many zeros do I have? Okay, so the next one's a little bit nicer. I'm going to wait for you guys. Those are nicer. Anybody want to try? 0, 0. Okay, so this is a +2. So that means I'm going to the left. So that means my vertex is going to be at -2, -1. So if I plot that point, that's going to be somewhere over here. And my graph opens down. Oh, that's a bad graph. Don't judge. So that is, we have none. We have no zeros. 0 zeros. Yeah.
So you switch that off to the machine.
Yeah.
So the graph goes.
Yes. Yeah. Yeah, let's have 2 of that. That will confuse you forever. It will. And then we'll do something very, very well that will be completely different that you're going to have to get another tattoo. I always recommend that you leave placement in 4 hours for your unit circle to get tattooed. Okay, last one. Okay, if you were to head to bed and you were the teacher in the class and you had given a 2 example and an example, anybody want to guess what that one's going to be? Okay. Trouble is I'm not going to give you 3 examples on your test, so you need to know how to do this, right? So my vertex is going to be where? 2 and 0. So there's nothing added here. So you can assume that as a +0, right? So my vertex is at 2, 0. So that puts me right here. And my graph opens up. Does it matter if it opens up or down? No. But we would have 1, 0. Okay? Easy peasy. Easy peasy. Oh, this is exciting. I love this question. And this is the one that you guys hate the most. Okay. Okay, we're going to create an equation. Okay, so people don't like this because it takes some thinking, and sometimes it takes us a little bit more thinking. So my equation form is y equals a bracket x minus h squared plus k. So what are these? My vertex. So I have two pieces of information. So the things I'm trying to find are, I'm trying to find my a value, my h value, and my k value. All right, so looking at this graph, where's my vertex? You sure? Positive? So you're telling my vertex is at 2, 1. Yeah. I believe it. Now, it's a +2. So is it going to be an add 2 or a subtract 2? It's going to be a subtract 2 squared plus 1. Okay, that's good. So I'm left only with one thing left to find. Okay, that wasn't too hard, right? Okay, so we got to find the a value. We got to find the one more thing. So what we're going to do is we're going to select a point. Oh, that's a yellow. That's not good. Okay, I guess this is step 2. Okay, you have to select a point that's not the vertex. Okay, I want you to select an easy point. If you were to find the easiest point on that graph to select, what would you select? I'd take the y-intercept that's occurring at 0 and 3. You can pick any point you wish. Just make sure it's an actual point. Okay, so then, once we've selected our point, we're going to substitute in these 2 values, the x and the y, for the x and the y. And then we're going to solve for a. Easy peasy. So my y was 3. My a, I don't know. 0 minus 2 squared plus 1. So I'm going to have 3 equals 1. sure about that? Right, because we know those two things are multiplied. We did that before, right? Okay, so 1 over 2. So I'm going to minus 1 from both sides. So I'm going to have 2 equals 4a, divided by 4, divided by 4. A is equal to 2 over 4. We always give it in the simplest form. So A is equal to 1/2. All right, now you can't leave it like that. We've got to write the equation. So we're going to take our 1/2 and we're substituting it back into that one. So my equation is going to be y equals 1/2 bracket x minus 2 squared plus 1. That is the equation of that graph. So not too terrible. You just got to find that other point and choose wisely, or you'll cry a little. These ones always trip you up. I guarantee you this will be on your quiz, and I guarantee you it will be on your exam. Probably on your exam too. Just saying. Hint, hint, nudge, nudge. All right. Exact same question, no picture. Can you do it? No, don't draw. Time for that in your life. Can you do it without it? Yep. Absolutely. Once you start it, I can totally finish it. Okay, so we know our vertex. So again, the form is y equals a bracket x minus h squared plus k. And the h and the k are where? There's your vertex, right? So I'm going to substitute those values in. So I have y equals a. Now it's a -2. So what's it going to be inside the bracket? +2. All right. So on the left, trying to find my a. But luckily, you have another piece of information. It says the graph passes through the point 0 and -8. So what are you going to do with these? Plug it into x and y. So that's going to go there. Oh, you're backwards. You get the idea. We'll go this way. See? Works now. So now I'm going to have -8 equals a 0. So flying through this, and you guys are like, how do we even have the first line down? And I apologize, because that's not fair. I didn't give you guys much time to work through the math. But you do have to substitute it in, and just make sure that you're substituting it into the correct places, that the x and the y, because they go x, y, but in our equation it goes y, x, so that I see that a lot. Like you put the 0 in for y, you put the -8 in for the x. Just so those are the things that I've seen before that cause a few tears. So you can do it when I give you a graph. You can do it when I don't give you the graph. You guys have amazing skills.